you out a little bit in learning how to calculate a quadratic model. This is from lesson 2.8, page 161, since you're going to be asked to calculate quadratic models for some of the data. I want to make sure you know how to do that. So if you go to the applets, again, you're going to click down here on the two quantitative variables, and then this box pops up. So this is where you're going to enter in the explanatory variable and the response variable. In our example, this was, I believe this was passing yards for a certain quarterback's, Brett Favre's career. He was 41 years old when he retired after that season, and this is basically each of the passing yards he had in each year that he was a quarterback. Or actually, I think this is other quarterbacks. I think this is like passing yards for different quarterbacks at certain ages. So anyway, I am going to show you, I've already entered in that data here. Age is the explanatory, passing yards is the response. So obviously, we're trying to see if there is a relationship between the age the player is and the amount of yards they're able to throw the ball in a given year. So I've already entered in this data, so I'm going to say begin analysis. And when I do that, a scatter plot pops up. But what I want to do is calculate a quadratic equation, which is what I have right here. And so I am going to go ahead and click on, once I've got that there, I'm going to make sure that I've calculated that. And then I am going to press the Calculate Other Regression Model. So what pops up is a parabola, which you should already know that any quadratic equations, a quadratic model, will always be some type of parabola. So that pops up, and then you can gather some information about it by coming down here. There is the quadratic model. Now remember that quadratic models are typically keeping the x squared term first, the x term in the middle, and then the single term without the variable. They have it in the reverse order, just kind of like they did with the linear model. But again, here's the number of quarterbacks they sampled. The standard deviation of between their passing yards was about 820.235. And then the correlation squared, the R squared, which is the correlation after having been squared, that information is listed all here. So again, variability here, it's kind of interesting. 13.9% of the variability can be attributed to age. So that's kind of interesting. You would think that that would play a bigger factor, but you can definitely see some unusual data. You would think that the older that they were, the less they'd be able to throw the ball. Yet you do find some higher ages that had some pretty decent yardage, passing yardages. And then you also see some where the player's very young and doesn't do very well, probably because they're younger. That also explains why you kind of have this parabola, because when you're young, you're inexperienced, so it's kind of low. You kind of peak in your mid-30s, and then when you get old again, then their passing yardage kind of goes down because you might be injured a lot. Muscles and bones just don't work the same way. So it kind of makes sense that this is a quadratic model. I'm a little surprised that there isn't more variability, but again, probably the reason why, a correlation here and the percentage, is because you've got young kids that can't pass a lot, and then you've got the older quarterbacks that can't pass a lot. So that's probably why the variability percentage for the reduction in yardages is so low. So that at least helps you get started, because you're going to be asked to calculate a quadratic model on your homework and also on your lesson application. So, I wanted to make sure that I kind of gave you a chance to kind of see how to do that using the applets.